All right, this is section 7.1, adjacent and vertical angles. And so we're starting a unit that has to deal with angles and triangles. And before we start, let's review some vocab from your 6th grade year. So we've talked about, we've got acute angles, right angles, obtuse angles, and straight angles are our 4 different types of angles we know so far. And acute angles are angles that are less than 90 degrees, so like a cute little angle. We've got right angles, which are exactly equal to 90 degrees. Obtuse angles, which are greater than 90 degrees, but less than 180, because if it's exactly 180, we call it a straight angle, and 180 degrees forms a straight line. So what we're going to do, to start with, we got 4 different clocks down here, and we can draw these different times on the clock to see which kind of angle they're representing. So the first one I have here is 9 o'clock. And so if we draw those the hour hand and the minute hand, the hour hand, remember, is the shorter one. And it's going to be pointing right at the 9. And then the minute hand's the longer one. It'd be pointing right at the 12 there. So that would be 9 o'clock. And that would be considered a right angle, which you probably could figure that out. That's a right angle. And then we've got 6 o'clock. And so at 6 o'clock, the hour hand is going to be pointing straight at that 6. The minute hand is going to be pointing up at the 12. And that would be a straight angle. And then at 10 o'clock, we've got the hour hand pointing at the 10 and the minute hand pointing again at the 12. That would be an acute angle because it's less than 90 degrees, smaller than a right angle. And then at 3:45, and if you're not careful, you could very easily draw the 3:45 going like this at the 3, and then the 9 obviously being the 45 minutes for the minute hand. But that's not what 3:45 actually looks like. 3:45 is going to be, I agree, the minute hand should be pointing right at the 9, but the hour hand is going to be really close to the 4. Not quite at the 4 yet. But really close to it because it's almost 4 o'clock, 15 minutes away. So at 3:45, we actually have an obtuse angle here, an angle that's larger than 90, but not quite a straight angle. All right, so these instructions actually refer to a picture on the next slide, but I'll go ahead and read it anyways. It says some angles, like angle A, which we'll take a look at, can be named by a single letter. If this does not clearly identify the angle, you should use 3 letters. And you should use capital letters. In geometry, when we're talking about angles and lines and rays and planes and all those, use capital letters. So remember when you're doing your homework over this section to turn your caps lock on or enter capital letters when you're talking about those angles. All right, so this is the picture that I was referring to, and you can see angle A. If I said angle A, everyone's looking at the same exact angle. You can see this right angle up here. This right angle would be angle A. But if I said, everyone look at angle B, well, it'd be difficult to know which angle I'm referring to. Am I referring to this right angle? Am I referring to this acute angle or even this acute angle? Or am I referring to the straight angle, which would be 180 degrees? So it's hard to determine. It's not as easy as it is when I say angle A and you know I'm talking about the right angle. So typically when we're labeling angles, if saying angle A, or in this case angle B, isn't specific enough, we use 3 letters. And so if you look at the instructions up at the top of the screen, it says that angle BDE would be how we would refer to this angle. So angle BDE, B would be the 1 point on the side, angle D would be the vertex, and then angle E is referring to this angle right here that I'm highlighting in green. You can see angle BDE. If I were just to say angle D, it'd be difficult to know which one I'm referring to, but when I say angle BDE, you can draw your eyes from B down to D, and then it said E. So we're talking about that angle there. And so the middle letter is always the vertex, or where the 2 rays meet. So for example, if I wanted to refer to this angle here that I'm coloring in purple, I could say either angle FEB, taking me from F to E to B, or I could say angle BEF, which is the exact same angle, just starting from the other end and going from B to E to F. So I have two ways that I could say that angle. I don't want to say angle E because I wouldn't know which angle I'm referring to, whether it's the purple one or whether it would be the one on this side here. All right, so let's look at this example. It says, use that figure to name each type of angle. First of all, a right angle. And they've already mentioned angle A, and so we could use angle A as a right angle because it meets at 90 degrees. So up here at the top left of our figure. I could also say angle F, or I could even say the angle I just referred to, angle FEB. That would be a right angle because it's on a square here. So angle FEB or BEF, however you want to say it, would also be a right angle. So now example B says an acute angle. In acute angle, we could use angle BDE that they've already got listed for us. So that little mark that I'm putting in front of these letters, that just means angle. And so that way you know you're not talking about a triangle, which also has 3 different letters that you would use. So angle BDE is this angle right here, and that's acute. You could also say angle, another way to say the exact same angle is angle EDB, would be the same exact angle. Or maybe I want to say this angle here that I'm doing in purple. And if I wanted to say that angle, how about angle BDC or angle CDB, however you want to think of it. Okay, so example C says an obtuse angle. And if you're looking up here, you may not see an obtuse angle. However, I am going to use the angle that is made by these lines here. And that would be an obtuse angle, and I just have to label it. So to label it, I could say angle ABD. B is the vertex, it's the middle point. I'm going from A to B to D. Or you could reverse it and say angle DBA, but you're talking about the same exact angle. So that would be an obtuse angle. And then example D says a straight angle, and I'm just going to use the straight line here at the bottom of the figure. There's also a straight line at the top of the figure that you could use. But angle FED or DEF, however you want to write it, could be a straight angle. Or if you wanted to say the angle at the top, angle ABC or CBA would also be a straight angle. So we have all 4 angle types in this figure: right angle, an acute angle, an obtuse angle, and a straight angle. All right, this next question says, how many angles are formed by the intersecting roads? What do you notice about these angles? Well, we actually have 4 different angles that are intersecting here. So I'm going to number them: 1, 2, 3, and 4. So we have 4 angles. And now I'm going to tell you what type of angles they are, because now we're going to get into the vertical and adjacent part of the lesson as it's titled. So we have 4 adjacent angles. And we have 2 pairs of vertical angles. So we have 4 pairs of adjacent angles, and then 2 pairs of vertical angles. So let's talk about what these angles are. Okay, so 2 angles are adjacent angles when they share a common side and have the same vertex. The word adjacent isn't just used in math. Sometimes we'll use that in geometry or really any conversation where you're saying 2 places are next to each other. The word adjacent just means next to. So for example, we could say New Hampshire is adjacent to Maine because it is next to. They share a common border. Indiana is adjacent to Ohio. It's adjacent to Illinois and to Kentucky and to Michigan. It shares a border with these other states. So, and then your next door neighbor, the one that lives right beside you, not across the road, but right beside you, would be adjacent to where you live because you share a common property border, usually a fence. So in this example, you can see angle 2 and 3, or angle 1 and 2, I should say, are adjacent. Even 1 and 4 are adjacent because they share a common side and a common vertex. But I wouldn't say that 2 and 4 are adjacent. I would also not say that 1 and 3 are adjacent. They may share a common vertex, but angle 1 and angle 3 don't share any common sides. That makes them not adjacent. So they share that vertex but not any side. So adjacent means they have to share a side as well. So in this example, let's look. It says name 2 pairs of adjacent angles. And so there's a ton of different ones you could give, but I'm just looking for ones that are next to. I'm just going to highlight this angle here in red, and then in purple I'm going to highlight this angle here. And they are next to each other. They share a common vertex, and they share a common side. In fact, if I highlight them, there's that angle in red, and then the angle in purple, you can see which side they're sharing. It's that AB side that I'm highlighting right here. So there's the common side. So they are adjacent. And so to label them, I would say angle, So I would say angle FBA. That's how I'm going to label that one, angle FBA. And it is adjacent to angle ABC. And remember, I'm using capital letters to label my angles. So those two angles are adjacent to each other. Okay, a second pair of angles, in fact, I could use the same exact angle I was using previously, angle FBA here. And then I could just say that it's adjacent to its other next door neighbor, which is this angle that I'm going to do in green right here. And so angle FBE, or EBF, however you want to say it. Those two angles would be adjacent to each other because they share a common vertex, B, and then they share this common side right there. All right, let's look at a new picture and see if we can do the same thing. Again, just looking at adjacent angles right now. We could say angle, I'm gonna make this a little bit more interesting. How about this angle here? That would be angle MJK, angle MJK using capital letters. And it's adjacent to, I can't pick the angle inside of it. That wouldn't work. It's got to be next to. They can't share any of the space. Just like your property and your next door's neighbor's property don't share any space. They just share a common fence or a common side. But I could say this angle here that I'm doing in blue, that'd be angle NJN, angle NJM, or MJN, however you want to say it. The only way you have to make sure you're saying it is you have to make sure J's in the middle. You can see in both these J's in the middle, it's that common vertex they're sharing. What I couldn't say is angle NMJ. There isn't an angle NMJ. It doesn't make sense. I have to make sure I'm using the correct terminology here. And then another one, let's see. I could say, let's erase this, angle QJK, this angle up here, angle QJK, and angle, let's see, I couldn't pick this angle here because it doesn't share any common sides, but I could pick this angle here, and so that would be angle KJL, angle KJL, or LJK, and those two angles are adjacent. All right, let's look at some homework questions. This is number 21. Determine whether the statement is always, sometimes, or never true. And it says when the measure of angle 1 is 70 degrees, the measure of angle 3 is 110. So if the measure of angle 1 is 70 degrees, it says the measure of angle 3 has to be 110. And so if you think about this, these are vertical angles. And we know vertical angles are congruent, and these two angle measures are not the same. So this would never be true. If the measure of angle 1 is 70, then the measure of angle 3 would also have to be 70 degrees because they are vertical angles. Number 22, same thing, always, sometimes, or never true. When the measure of angle 4 is 120 degrees, the measure of angle 1 is 60 degrees. So if angle 4 is 120 degrees, it says angle 1 would be 60. Well, here's what we know. These two angles together sit on a straight line, and we know straight angles measure 180 degrees. So these two angles are adjacent to one another. Together they form that straight angle. And so together they should add up to make a 180 degree straight angle, and 120 plus 60 is 180 degrees. So this is always true. If the measured angle 4 is 120, angle 1 has to be 60. In fact, not just angle 1, but angle 3 would have to be 60 degrees as well. Number 23, angle 2 and angle 3 are congruent. In this picture, it does not look like angle 2 and angle 3 are congruent because they aren't. But if any two lines meet, our lines could look like this. And so angle 2 and angle 3 are adjacent to one another. They are not vertical. And vertical angles we know are congruent. But they're adjacent to one another. The only way that they would be congruent is if angle 2 was a right angle. That would make angle 3 also a right angle. And not only that, but it'd make all of them right angles. These would be just two perpendicular lines. So the answer to this one is sometimes. In the picture they've got drawn up here, I would say no. But if I were to angle those lines so that they met at right angles, then angle 2 and angle 3 could be congruent only if they're all 90 degrees. And number 24, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Okay, so that's a lot. Let's kind of break that down. The measure of angle 1 plus the measure of angle 2. So angle 1 plus angle 2. Well, here's what we know about those two angles. They're adjacent to one another. Together they sit on a vertical, or on a straight line, I should say. And so together angle 1 plus angle 2 will be 180 degrees because they are sitting on that straight angle together. And then angle 3 and angle 4. Well, angle 3 down here and angle 4 are also sitting, well, they're underneath, but they're sitting on that straight angle as well. So angle 3 plus angle 4 also is 180 degrees because they're adjacent to one another, and together they make that straight line as well. And so this would be always true. The two angles on top, angle 1 and 2, would have to make 180 degrees, and the two angles on bottom added together would also have to be 180 degrees.